Okay, this is the solutions to the review. So let's jump into this. Our first question is having us analyze this graph. So what we need to do here is, so looking at the graph, we have a position versus time graph. The first thing wants to know the initial position of the object. This is where we start. And for our graph, it's the y-intercept. So looking right here, my y-intercept is -4 meters. That's my initial position. The next thing I want is the velocity of the object at 1 second. Now, this is a position versus time graph. So something that's really, really important for us on a position versus time graph that we have to keep in mind is that we cannot read velocity from the graph. The information that we get when we just read this graph is position and time information, not velocity. In order to find velocity, we have two choices. One is to say that velocity is the change in position over time. The other one is to say that it is the slope of position versus time. So when we look at the slope of position versus time, we can figure out things about the velocity. Again, that's not just reading the graph, that's looking at the slope. While we're here talking about slope a little bit, just to give us some good words to talk about when we have slope, this is a positive slope, so that means it's a positive velocity. This is a negative slope, so it's a negative velocity. And this is a slope of 0. That means we have a 0 velocity. So, at 1 second, I want to look at this entire line right here. Because when it says the velocity of the object at 1 second, what it means is the slope at 1 second. Well, that's one whole line segment, so I want the slope from that entire line segment. So we're going to take and look at velocity is change in position over time. So if we start at -4 and we end at 6, our change in position goes from -4 to 6. That's a positive 10 meters. And we do that whole motion in 2 seconds. So we get 5 meters per second. The velocity of the object at 3 seconds. Now here, I know I have a negative velocity because I have a negative slope. So I'm going to look at this segment of the line in red, and we go from 6 meters down to 2 meters. So for that velocity, we do delta x over time. That delta x is -4 meters. I start off at 6, I have to go backward 4 meters in order to get to 2. And that motion takes me from 2 seconds to 5 seconds. So that motion takes me 3 seconds. So my velocity is there is -1.33 meters per second. And it's a good thing that it's negative because that's a negative slope. It needs to reflect that negative slope. The velocity of the object at 6 seconds. So for the velocity of the object at 6 seconds, we're looking at this section of the line. But if we look over here, I see that that slope is 0. If the slope is 0 at 6 seconds, then the velocity is also 0 at 6 seconds. So I don't have to do any more work than that. The velocity at 6 seconds is 0. Part E, the velocity of the object at 9 seconds. Okay, we're moving on to the next segment of line. 9 seconds, next segment. This is the segment of line that we want to calculate the velocity for at 9 seconds. We start off at 2 meters, and we end up at -4 meters. So my velocity is the change in position over time. If I go from 2 to -4, it's 2 all the way down to -4, my change in position is -6 meters. We go from 7 seconds to 10 seconds. So that's over 3 seconds. So we get -2 meters per second for that velocity. So what we just did here was find the slope of each segment, which is the same thing that's finding the velocity of each segment. Part F wants to know every time interval for which the object is at rest. So when we are at rest, it's every time interval for which the velocity is equal to 0. And what that means is we have a flat line. Now, on our graph, we have a flat line from 5 seconds to 7 seconds. Those are the only times when we are at rest. So 5 seconds to 7 seconds. That's all I mean by time interval, what chunk of time. Write a description of how someone might walk to create the graph as shown above. All right, so we look at this section by section. Start at -4 meters and walk to +6 meters in 2 seconds. That's the first thing. Then walk back to 2 meters in 3 seconds. Stand still for, let's look at that, 2 seconds. That's the interval that we're at rest. And then walk back to -4 meters in the last 3 seconds. That would be one way that you could write that out. Your narrative can look a little bit different, but it needs to include mostly the same information. Part H. So, the time equals 7 seconds is telling me where I am at the beginning of this motion. So looking at this problem, that's my final position. And I want to calculate the time. So my givens so far are that the final position is -20 meters. My unknown, based on my question, is the time. At 7 seconds, I know some things. First, I know that at 7 seconds, my velocity begins to be -2 meters per second. So my velocity is -2 meters per second. And I know that at 7 seconds, my initial position, if we look at our graph, right here at 7 seconds, my initial position is 2 meters. So those are my givens, the final position of -20 meters, the velocity of 2 meters per second, the initial position of 2 meters. My unknown is the time. The equation that's going to help us, because I have the initial position, x final equals x initial plus velocity times time. So I know x final, -20 equals -2 plus velocity, -2 times time. When we plug these things in, it's super important that we plug them into the right spot. So I'm solving for time. So the first thing I need to do is deal with adding and subtracting. So I'm going to add 2 to, I apologize, that's not a -2, that's a +2. So +2. So I'm going to subtract 2 from both sides. So I get -22 is equal to -2t. Divide both sides by -2. And my time comes out to be 11 seconds. That's when I'm at 20 meters. Number 2, group of students use a motion sensor to graph their motion as they walk back and forth. Complete the other graph, then write a description. I will let you write the description on your own. What I'm going to do is help you create the other graph. So, in order to create the velocity versus time graph, I need to find the velocity for each section here. I have 4 sections. So let's label them. Here's my first section, second section, third section, fourth section. So my first section goes from 0 seconds to 2 seconds. My velocity on that first section is going to be my change in position over my change in time. So if we look here, we start off for section 1 at 5 meters and we end up at 1 meter. So my change in position over time is going to be negative 4 meters over, and that takes place over 2 seconds. So that velocity is negative 2 meters per second. That's velocity 1. Velocity 2, we start off at 1 meter and we end up at 2 meters. So for velocity 2, velocity is change in position over time. We go from 1 to 2, so it's plus 1 meters, and then that chunk takes me from 2 seconds to 4 seconds, 2 seconds. So that velocity comes out to be 0.5 meters per second, and it's positive. Let's give us some room on this graph. If we erase that and look at our third chunk, we don't even have to calculate it. I can see from the third chunk that I have a flat line, and I know that a flat line has a slope of 0. And I know that a slope of 0 means that we have a velocity of 0 for the third chunk. And then for the fourth chunk, we start off at 2, and we end up at 4. So the velocity is delta x over time. So that's positive 2. Going from 2 to 4 is positive 2. And that takes me from 5 seconds to 6 seconds. So that's over 1 second. That velocity is positive 2 meters per second. Now that we have all the velocities, and this was very similar to what we did before, we can graph those. What we're going to do is graph the velocity for each chunk of time. So the first chunk of the graph takes me from 0 seconds to 2 seconds. So on the velocity graph, from 0 seconds to 2 seconds, my velocity is negative 2 the entire time. So I have a constant velocity of negative 2 for the entire first 2 seconds. The second chunk takes me from 2 seconds to 4 seconds. So from 2 seconds to 4 seconds, my velocity is 0.5 meters per second. So we're going to go up here to 0.5 meters per second for another 2 seconds. Positive 0.5 meters per second. So it's up on the other side of the graph. And then my next chunk goes from 4 seconds to 5 seconds, and we have a velocity of 0. So for the next 1 second, our velocity is 0. And then the last chunk goes from 5 seconds to 6 seconds, and my velocity is 2 meters per second. So 5 seconds to 6 seconds, and then a velocity of 2 meters per second. And now we have a graph of velocity versus time. Part B, we're going to take all this velocity information and we're going to find position information. So to do that, what we have to do from this velocity graph is find the change in position for each section. So to find the change in position for each section, let's look at the first section. The first section goes from here to here. That takes me from 0 seconds to 4 seconds. So for our first one, I know the velocity is 1.5 meters per second. I can read that right here. So that's my velocity for the first section. And that's going to be equal to the change in position, which I don't know, over the time of 4 seconds. So to find that velocity, I'm going to multiply both sides. Sorry, to find that change in position, I'm going to multiply both sides by 4. Those 4's cancel out, and I get 6 meters is equal to my delta x. So for the first chunk of time, from 0 seconds to 4 seconds, I go 6 meters. So this tells me that I start off at 0 meters. Assume the initial position is 0. And then in 4 seconds, I end up going 6 meters. So that's the first line. That's section 1. Section 2, we run from 4 seconds to 6 seconds. So in section 2, again, velocity is delta x over time, so the velocity, -2, is equal to delta x over the time. That time interval is 2 seconds. So we're going to multiply each side by 2. That 2 goes away. And so I have -4 meters is equal to my delta x. So for section 2, I start off at 6 and then I go -4 meters. That means I'm going to end up at 2. So at 6 seconds, I go from 6 all the way down to 2 because that's -4 meters. So this is what my path looks like there for that last chunk. Sorry, for the second chunk. And then for the last chunk, chunk number 3, we're going to do the same thing. I know that velocity is delta x over time. So my velocity for that last chunk is 1 meter per second. That's equal to delta x over, we go from 6 to 7.5, 1.5 seconds. So that delta x, multiply both sides by 1.5. Delta x comes out to be 1.5 meters. And so for that last chunk, I go an additional 1.5 meters. So by the end of the graph, I go from 2 to 3.5, because that's 1.5 meters bigger. And that's what my position versus time graph looks like. For each interval, I had to calculate the change in position. Part C, we have Tom. So we're going to look at Tom. He starts 2 meters away from the motion sensor. So that's my initial position. He walks away from the motion sensor at 0.5 meters per second for 4 seconds. That's one chunk of our motion. He then stands still for 1 second. That's the next chunk of our motion. And then he moves back towards the motion sensor 3 meters in 2 seconds. So in order to graph both of these, we need to figure out what's going on for Tom in the first one, the second one, and the third one. And for each of those, what I want is the velocity, the change in position, and the time. So in our first chunk, we know that he starts at 2 meters, so I'm going to go ahead and put that right there. But he walks away from the motion sensor at 0.5 meters per second. That's my velocity. 0.5 meters per second for 4 seconds. That's my time. 4 seconds. What I want is my delta x. So from what we were seeing before, velocity is delta x over time. Multiply both sides by time, and we get delta x is velocity times time. Divide both sides by velocity, and we see that time is delta x over the velocity. There's another video where we talked about how to get all 3 of those. You really do need to know how to do that. But to get our delta x, it's going to be the velocity 0.5 times the time of 4 seconds. So my delta x comes out to be 2 meters. So in the first 4 seconds, we go 2 meters. So if we start at 2 and we go 2 meters, we end up at 4 meters. So that's my first chunk there for the first 4 seconds. And then for the velocity graph, I know that for the first 4 seconds, my speed is 0.5 meters per second. For the second chunk, what they tells me is that he stands still for 1 second. So that means the velocity is 0 meters per second because we're standing still. The time is 1 second, and if we're not moving, the delta x is 0. So that means for this entire second, we're going to have a flat line for velocity. Sorry, we're going to have a flat line for position because the velocity is 0. And then on the velocity graph, we're going to graph a 0 velocity because we're not moving. Our last chunk means he moves towards the motion sensor at 3 meters in 2 seconds. So 3 meters is my displacement. I know that's a displacement because it's in meters. And because it's towards the motion sensor, it's getting closer to it, we're going to move from 4 to something smaller, and it's going to take place in a time of 2 seconds. So now I want the velocity, that's delta x over time, so negative 3 over 2, that velocity is negative 1.5 meters per second. So I can graph this last chunk. It says in 2 seconds, I go negative 3 meters. So that means at 7 seconds, I end up 3 meters behind 4. So I go from 4 meters down to 1 meter because that's moving towards it 3 meters. And then my speed is negative 1.5 meters per second for the last 2 seconds. So 1, 2. There are my graphs based on that little narration. All right, we have Ramon walking 2 miles north in half an hour. He hurts his ankle. Takes another 1.5 hours to walk 4 miles north. After resting, he goes back to the south 2 miles in 1 hour before giving up calling for help. So the displacement for his trip. Let's look at his trip. So he goes 2 miles north, and then he goes 4 miles north, and then he goes 2 miles back. So overall, he went 6 miles north, then 2 miles back. His displacement is how far from start to finish. That's 4 miles to the north. So his displacement is 4 miles to the north. And remember, displacement is how far is he from the start. Distance is how far did he go on that poor hurt ankle of his. How far did his feet actually carry him? Well, that's all those things added together. So we get 8 miles. To get average speed, and this is important, speed is distance traveled over time. So for distance traveled over time, we're going to use the 8 miles, and then we're going to use the total time, half an hour, 1.5 hours, so we're up to 2 hours, 3 hours. So 8 miles over 3 hours. When we calculate that out, we get his average speed to be 2.66 miles per hour. Remember, for speed, we had to use distance traveled to calculate. To get average velocity, it's our displacement over our time. Well, our displacement is 4 miles. So it's going to be 4 miles divided by 3 hours. And that's 4 miles to the north. So we end up with 1.33 miles per hour to the north. That's our average velocity. So the things that we need to keep in mind from this are that average speed is distance traveled over time. Average velocity is displacement over time. And so we have to use those things to calculate it. Number 4. An object starts at x equals negative 5 meters, goes forward at a constant velocity. At 10 seconds, it's at 15. At what time will the object reach x 45? So in order to do this, the one thing we don't have is velocity. We're going to need that here. So if we look at it, x is negative 5, so my initial position is negative 5 meters. Time 10 seconds, so time of 10 seconds, the object is at 15 meters. X final is 15 meters. If I want the velocity, it's going to be the change in displacement over the time. So if I go from negative 5 to 15, my displacement is positive 20 meters over 10 seconds. So 2 meters per second. Then the actual question is, what time will the object reach x equals 45 meters? So now, for this problem, the initial position is 15 meters. Tell you what, let's start with the very beginning of the problem. So the initial position, what we have for the beginning of the problem is negative 5 meters. The velocity we just found is 2 meters per second, and the final position is 45 meters. What we want now is the time. So in order to do this, the equation that we're going to use is x final equals x initial plus velocity times time. We're going to plug in our numbers. So 45 is equal to -5 plus 2 times the time. And we're going to solve for the time here. So we'll add 5 to both sides because we want to deal with the addition first. So 50 is equal to 2 times the time. Divide both sides by 2. 25 seconds is how long it's going to take. That gets me there. Number 5, an object starts at 15 and moves backwards. How long does it take the object to reach 0? So if we're going to go from 15 to 0, my delta x is -15 meters. The velocity is -0.2 meters per second. Those are my givens. My unknown is the time. So the equation that we're going to use, velocity is delta x over time. So when we substitute and put in our numbers, I get -0.2 equals -15 over the time. To solve for time, I multiply both sides by time. It goes away. So I have time times -0.2 equals -15. And to solve for time, we're going to divide both sides by -0.2. So the time comes out to be -15 divided by -0.2, which comes out to be 75 seconds. What's the position of the object at t equals 50 seconds? So here, for this chunk of our motion, the initial position is still 15 meters. The velocity is still -0.2 meters per second. And the time is 50 seconds. What we want is the final position. X final is velocity times time plus the initial position. So it's going to be -0.2 times 50 plus 15. So -0.2 times 50 is -10. So -10 plus 15 means I'm going to be at 5 meters. You can put all that in your calculator. Number 6, for each of the following, sketch a graph of position versus time. So we have position versus time for each one of these three things. Position versus time, position versus time. So if we look at this, the object starts with positive initial position. That's my y-intercept. It's telling me that I begin here with positive initial position and then moves backwards. That's telling me about my slope. If we move backwards, that slope is going to be negative. So we start with positive initial position and then we move backwards with negative slope. An object starts at 0, so we start at 0, and has positive velocity. That means positive slope, because slope and velocity are the same thing. And then an object starts behind 0, that's my initial position, has a constant negative velocity. That means I have a negative slope.